Oropouche fever is a viral disease often mistaken for dengue fever. This mosquito-borne illness, primarily found in South America, is spreading, causing global concern. Characterized by sudden fever, headaches and muscle pain, Oropouche fever can halt daily life. While rarely fatal, its impact on communities is significant. This essay explores Oropouche fever's transmission, symptoms and recent emergence. Climate change and environmental degradation create breeding grounds for the virus. Recent outbreaks remind us of our interconnectedness with nature. Altering ecosystems allows pathogens to jump from animals to humans. Addressing factors behind diseases like Oropouche fever is crucial for global health. Imagine a creature so small it can slip through the eye of a needle, yet powerful enough to bring entire communities to their knees. This is the midge, a tiny fly that transmits Oropouche fever. They thrive in tropical regions, breeding in stagnant water. When an infected midge bites a human, it injects the Oropouche virus. The virus multiplies rapidly, causing debilitating symptoms. Midges are the primary vectors, but mosquitoes also spread the virus. Multiple vectors increase the virus's potential for rapid spread, making control challenging. Oropouche fever often masquerades as other mosquito-borne illnesses, making diagnosis a tricky endeavor. Its symptoms, which typically appear within a week of being bitten by an infected insect, closely resemble those of dengue fever. Patients experience a sudden onset of high fever, often accompanied by chills, excruciating headaches, and severe muscle and joint pain. Nausea and vomiting are also common, leaving individuals feeling weak and debilitated. In some cases, Oropouche fever can also cause a rash, further complicating diagnosis. While most people recover from the illness within a week or two, some experience lingering fatigue and joint pain for several weeks. The similarities between Oropouche fever and dengue fever highlight the importance of accurate laboratory testing for diagnosis. Misdiagnosis can lead to inappropriate treatment and delay necessary public health interventions. Early and accurate identification of Oropouche fever cases is crucial for implementing control measures and preventing further spread. As our planet warms and human activities continue to reshape natural landscapes, we inadvertently create pathways for infectious diseases to emerge and spread. Oropouche fever is a prime example of this phenomenon. Deforestation, driven by agricultural expansion and logging, destroys natural habitats and forces wildlife into closer contact with humans, increasing the risk of zoonotic diseases spilling over into human populations. Climate change, with its rising temperatures and altered rainfall patterns, further exacerbates the situation. These shifts can expand the geographic range of disease vectors like mosquitoes and midges, bringing them into contact with new and susceptible populations. Moreover, urbanization, with its sprawling slums and inadequate sanitation, provides ideal breeding grounds for disease-carrying insects. The combination of these factors creates a perfect storm for the emergence and spread of mosquito-borne illnesses like Oropouche fever. Addressing these underlying drivers is crucial for mitigating the risk of future outbreaks. Section 5. The alarm bells ring recent outbreaks. In recent years, Oropouche fever has begun to make headlines, with outbreaks reported in several South American countries, including Brazil, Peru, and Venezuela. These outbreaks, often characterized by a sudden surge in cases, have overwhelmed healthcare systems and disrupted daily life. The increasing frequency and intensity of these outbreaks highlight the growing threat posed by Oropouche fever. The virus's ability to spread rapidly through mosquito and midge populations, coupled with the lack of immunity in many communities, raises concerns about its potential to cause widespread epidemics. The recent outbreaks serve as a wake-up call, urging us to strengthen surveillance systems, develop effective control strategies, and invest in research to better understand and combat this emerging threat. Failure to do so could have dire consequences, particularly for vulnerable populations in resource-limited settings. Section 6. Unprepared and vulnerable. A call to action. Despite the growing threat of Oropouche fever, the world remains woefully unprepared to confront this emerging infectious disease. There is no specific treatment for Oropouche fever, and existing control measures primarily focused on reducing mosquito and midge populations have proven inadequate in preventing outbreaks. The lack of a vaccine further compounds the challenge, leaving communities vulnerable to the debilitating effects of the virus. The international community must prioritize the development of effective vaccines and therapeutics for Oropouche fever, along with diagnostic tools for rapid and accurate case identification. Equally important is the need to strengthen public health infrastructure in at-risk regions, including surveillance systems, laboratory capacity, and healthcare workforce training. Community engagement and education are also crucial for raising awareness about Oropouche fever, promoting preventive measures, and ensuring early detection and treatment. Section 7. Understanding the enemy, the importance of research. To effectively combat Oropouche fever, we need a deeper understanding of the virus itself, its transmission dynamics, and the factors that contribute to its emergence and spread. Research is essential for developing targeted control strategies, designing effective vaccines and therapeutics, and predicting future outbreaks. Scientists are working tirelessly to unravel the mysteries of Oropouche virus, studying its genetic makeup, its interactions with host cells, and its ability to evade the immune system. This research is crucial for identifying potential drug targets and developing novel antiviral therapies. Furthermore, ecological studies are needed to better understand the role of environmental factors such as deforestation, climate change, and urbanization in driving the emergence and spread of Oropouche fever. This knowledge will be invaluable for developing effective prevention strategies and mitigating the risk of future outbreaks. Section 8. Breaking the chain, prevention strategies. Preventing the spread of Oropouche fever requires a multi-pronged approach that targets both the virus and its vectors. Vector control measures, such as insecticide spraying, larval source management, and the use of bed nets, are essential for reducing mosquito and midge populations and limiting human vector contact. Community-based interventions, including public education campaigns, community cleanup drives to eliminate breeding sites, and the promotion of personal protection measures like wearing long clothing and using insect repellent, can further reduce the risk of infection. Early diagnosis and isolation of infected individuals are also crucial for preventing onward transmission. Rapid and accurate diagnostic tests are essential for identifying cases early in the course of illness, allowing for prompt treatment and the implementation of control measures to prevent further spread. Section 9. A global challenge, collaboration, and preparedness. Oropouche fever, like many emerging infectious diseases, knows no borders. Its emergence in South America and its potential to spread to other regions underscore the interconnectedness of global health security. International collaboration and cooperation are paramount for effectively addressing this shared threat. Sharing of information, expertise, and resources is crucial for strengthening surveillance systems, developing diagnostic tools, and coordinating control efforts. Joint research initiatives can accelerate the development of vaccines and therapeutics, while capacity-building programs can help resource-limited countries strengthen their public health infrastructure. By working together, we can enhance global preparedness for Oropouche fever and other emerging infectious diseases, mitigating their impact on human health and well-being. A coordinated global response is essential for protecting vulnerable populations and safeguarding global health security. Section 10. Oropouche fever, a reminder of our interconnected world. Oropouche fever is a stark reminder of our interconnectedness with the natural world and the consequences of disrupting delicate ecological balances. As we continue to encroach upon and alter ecosystems, we create opportunities for pathogens to jump from animals to humans, potentially triggering global health emergencies. The emergence and spread of Oropouche fever underscore the urgent need for a One Health approach, recognizing the interconnectedness of human, animal, and environmental health. By addressing the root causes of zoonotic diseases such as deforestation, climate change, and wildlife trade, we can reduce the risk of future pandemics. Investing in research, strengthening public health infrastructure, and fostering international collaboration are crucial for combating Oropouche fever and other emerging infectious diseases. By working together, we can create a safer and healthier future for all. Let us heed the warning of Oropouche fever and take decisive action to protect our planet and ourselves.
So hit that subscribe button, ring the bell for notifications, and let's turn the page on a new adventure together. Get ready to experience books like never before, only on VBook 360. Like, comment, and share to support the channel and keep the video magic alive. Thank you for stopping by. And remember, every video has a story, and every story deserves to be shared. See you in the next video.